Copyrights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. And this is the book Mathematics for IIT-JEE Main and Advanced by M.L. Khanna sir. And I am here, Subuh Nadeem, which is introducing you to the basic concepts and some illustrations and exercises of the books. And you will get an overview of the book about what the examples are, what the questions are, and what are the theories beyond the success of this book. So we will see here few chapters. So the next chapter which we are discussing is Ellipse, and this is chapter number 21. So we'll start with some basic concepts of ellipse here. First of all, we know that eccentricity is a term which is used for all the conic sections, and in case of ellipse, eccentricity is less than 1. That is, PS by PM is actually E, which is less than 1. What is PS? As we know, S is the focus of this ellipse and M is the perpendicular on the directrix of this ellipse. And as we see here, that basically this PM and this PS, this ratio is equal to E, which is actually less than 1. If we take the corresponding focus here, S dash, and the directrix here, then the ratio of PS dash by PM dash is also equal to E. So this is what we know about ellipse. If we come to the equation of ellipse, before that we know the coordinates of the focus. So this is A, E, comma 0. The vertex is A, comma 0. And the directrix is X is equal to A upon E. Similarly, if we talk about the left hand side, the directrix is X equal to minus A by E. Focus is minus AE, comma 0. And this is the origin, which is the center of the ellipse. This is the vertex, which is minus A, comma 0. Now if we come to the equation of this ellipse, this is X square by A square plus Y square by B square is equal to 1. Now what is B square here? As we have A and E, but there is no B in the definition of ellipse, so we can say that B square is nothing but it is actually A square into 1 minus E square. And geometrically, this point is 0, comma B, and this point is 0, comma minus B, where the ellipse is intersecting the y-axis. So y-intercepts of the ellipse are B and minus B, and x-intercept are A and minus A. Now if we talk about what other terms can be associated with an ellipse, so there is a latus rectum. As we studied in parabola also, this is a focal chord and it is perpendicular to the axis. So it is the major axis here. So this latus rectum is having length 2b square by A. Now students, can you tell how we get this latus rectum length as 2b square by A? So as we know that this point over here, which is suppose Q, and this point is Q dash, two extremities of the latus rectum. So Q can be said to be AE, comma beta, where beta is not known. A is the x coordinate of the focus, which is same as the x coordinate of the extremity, and we put in the equation. So x square by A square will be A square E square by A square. Y square by B square will become beta square by B square is equal to 1. Now when we cancel A square here, it will become beta square is equal to B square into 1 minus E square, right? Now what is 1 minus E square? It is B square by A square. So this will become B to the power 4 by A square. What it means? It means that this beta is equal to B square by A. So this beta is equal to B square by A, and it is plus minus both. So basically if we take this endpoint, this is AE, comma minus beta, which is minus B square by A. So the total length of the latus rectum is 2B square by A here. Now if we talk about further terms associated with ellipse, so first we say the focal chord. The focal chord is a chord of the ellipse which passes through its focus, that is AE comma 0, or it passes through another focus which is minus AE comma 0. So we say that there are two foci here. Now there is a tangent at vertex which is x is equal to A and x is equal to minus A. There are two tangents at two vertices. What is another definition of an ellipse? There is another definition of an ellipse which is very important for us. Another definition says that if we take a point P on the ellipse and we take its distance from S dash and S, and we take PS dash plus PS. So as we know, PS dash is E PM dash and PS is E PM. We can write like this. Now what is PM dash plus PM? As we know, PM dash is the distance from the directrix. So this is PM, and PM dash will be from this directrix. So this is x is equal to minus A by E. Now if we add them, we will get MM dash, which will be equal to, actually, as this is A by E, this is minus A by E, so 2A by E, which is equal to 2A, which is a constant. So this is another definition of an ellipse which does not include eccentricity in its definition. It simply says that if we have two fixed points and we take one point as minus A comma 0, another point as A comma 0, and there is a point P, and if its distance from A comma 0 and minus A comma 0 we add up and it is always constant, then it is an ellipse. So PS dash plus PS is equal to 2A, which is always constant, is an ellipse. What about shifted ellipse? Shifted ellipse, as we studied in shifted parabola, that if we take the center as alpha comma beta, so its center is alpha comma beta, not origin, and then we want to find the equation of the ellipse. So it is x minus alpha whole square by A square plus y minus beta whole square by B square is equal to 1. Now as we know, what is A and B? A is the semi-major axis and B is the semi-minor axis, because 2A is the major axis. So length of the major axis is 2A and length of the minor axis is 2B. So semi-major axis is B, semi-major axis is A and semi-minor axis is B. So this is what we have written here. Next, what we have important with us is equation of a tangent to a parabola, which is t is equal to 0. So if we have, ellipse. So if we have an ellipse and we take a point P x1 comma y1 on that ellipse, then equation of the tangent will be x1 by A square plus y1 by B square is equal to 1. This is the tangent, equation of the tangent at x1, y1. Parametric point can be taken as A cos theta, comma B sin theta. So if we take this parametric point, this will automatically satisfy the equation of the ellipse. X square by A square plus y square by B square is equal to 1. Now, if we want to find the geometrical meaning of this theta, which is called the eccentric angle, so we can understand by drawing auxiliary circle. What is an auxiliary circle? Auxiliary circle is a circle which is like this. Diameter is the major axis, or radius is the semi-major axis. So this is x square plus y square is equal to A square. Now if we take this point and draw up a perpendicular here, then this point is A cos theta B sin theta, and the point Q here is A cos theta comma A sin theta. And if we join this Q with this, then this represents theta, which is the eccentric angle here. So this is the geometrical meaning of the eccentric angle, and the parameter is theta over here. Now if we want to write in parametric form the tangent, then this will be x by A cos theta plus y by B sin theta is equal to 1. After putting x1 as A cos theta and y1 as B sin theta. Now we have something called director circle. But before studying director circle, we have to study tangent in the slope form. So if we have a line y is equal to mx plus c, which is a tangent to the ellipse, and this is the ellipse we have. So if this is the tangent, then there could be two tangents of the same slope, as we studied in circles in the volume 1 also. So what is that intercept c? That intercept c is plus minus root over a square m square plus b square. So this is the plus intercept, this is the minus intercept. So these are the two tangents with a given slope m. And the equation of the tangent will be y is equal to mx plus minus root over a square m square plus b square. Now if we talk about chord of contact, so if we take ellipse and there is a point outside the ellipse and we draw two tangents to it, then the point of contact is joint and it is called chord of contact. And that chord of contact equation can be found out as t is equal to 0 if the point is x1 comma y1. Again, if the midpoint of a chord is given, so if we have a chord like this and its midpoint is given x1 comma y1, then what is the equation of this chord? This is t is equal to s1. So this length is equal to this length. So these are some of the standard results which are applicable in all conic sections. Just the equation changes, but the resemblance is same. Now we talk about some questions here. The following equation represents an ellipse. Find the center and the foci of the ellipse. How should the axis be transformed so that the ellipse is represented by the equation x square by 25 plus y square by 16 is equal to 1. So we can write this equation as x minus 3 whole square, and when we divide by 400 it will be 16 here, and we divide by 400 here, it is 25 here. So one thing is very important here. This is actually 16, which is smaller than 25. So you can say that this is a square and this is b square. So this is of the form x square by b square plus y square by a square is equal to 1. So it is a vertical ellipse because the major axis is along the y axis. Now if you want to find the center and the foci of the ellipse, so first of all the center of the ellipse. Center of the ellipse is 3, 0. So 3, 0 will be on the x-axis like this. Now it is a vertical ellipse like this. And if we talk about the foci, then foci will be somewhere here. So its x-coordinate is fixed, which is 3. And what about its y-coordinate? Y-coordinate is, so this will be, a is 5, b is equal to 4, and eccentricity is b square is equal to a square 1 minus e square. So if you want to find AE actually here, so AE will be a square e square will be equal to a square minus b square, which is 9. So AE is equal to plus minus 3. So you can say that 3, 3 is one focus and 3, minus 3 is another focus. So this is how we find the foci. As we know, AE, 0 changes to 0, AE, and since it is shifted, so it is not 0, AE, but it is alpha, AE. Now next thing what we have to understand here is the other part of the question. How should the axis be transformed so that the ellipse is represented by the equation x square by 25 plus y square by 16 is equal to 1. So for that, first this axis will be shifted towards right by a distance 3, and then it will be rotated by 90 degree. Then this will happen. So this is x, this is y, and if you transform this axis to the right by a distance 3, so in the next step what will happen? This will be like this. Now this is y, this is x, and now the equation will become x square by 16 plus y square by 25 is equal to 1. Now in the next step, you rotate it. So when you rotate it, what will happen? X will come here, Y will come here, and this is the equation. Now this is horizontal. If you take X like this, and this is Y. So you are taking Y as horizontal, X as vertical, but X axis is generally horizontal. So you have to visualize from the left hand side, and from the left hand side if you visualize, you will see that the equation now is x square by 25 plus y square by 16 is equal to 1. Now let us come to the next question. This question says an ellipse has eccentricity half and one focus at the point p half comma 1. So eccentricity is equal to half and one focus at the point p half comma 1. So this is the focus. Its one directrix is the common tangent nearer to the point P to the circle x square plus y square equal to 1 and the hyperbola x square minus y square equal to 1. So if we talk about the circle x square plus y square is equal to 1 and hyperbola x square minus y square is equal to 1. So there are two common tangents. Which common tangent is it is talking about? Nearer to the point P. So point P is half comma 1, which is somewhere here. So this is the tangent which it is talking about, that is x is equal to 1. Now it is saying the equation of the ellipse in the standard form is. So now let us talk about the equation of the ellipse. So this is the directrix. Directrix is x is equal to 1. Right students, I hope you have understood this diagram. This is the circle x square plus y square equal to 1 and this is the hyperbola x square minus y square equal to 1. These are the two common tangents and this is the tangent which is acting as the directrix of the ellipse. Now, if we take x is equal to 1 as the directrix, this is the y-axis, this is the x-axis, and then we are talking about the equation of the ellipse in the standard form. Now we have eccentricity half and focus at half comma 1. So half comma 1 may be somewhere here. So this is the focus. And its eccentricity is half. So the ellipse diagram would be something like this, that this way. This is how you are drawing the ellipse. Now the distance between the focus and the directrix, that is actually A by E minus AE, which is coming out to be 1 minus half, half, and E is equal to 1. So A minus A is equal to half. So of course E cannot be equal to 1, E is 1 by 2. As it is not parabola, it is ellipse. So E is 1 by 2, so 2A minus A by 2 is equal to half. So this will become 3A by 2, which is A is equal to 1 by 3. This is the semi-major axis. And when we talk about B, so B square is equal to A square into 1 minus E square. So A square will be 1 by 9 and 1 minus E square is 3 by 4. So this will become 1 by 12, which will be giving you B as 1 by 2 root 3. So this is the semi-minor axis. Now the equation of the ellipse in the standard form is, so equation of the ellipse in the standard form, its center also we haven't found out. We have to find its center also. So what is the difference between the center and the distance and the focus? So that is AE. So AE is actually equal to, A is 1 by 3, E is 1 by 2. So AE is 1 by 6. So the center will be half minus 1 by 6, that is equal to 2 by 6, that is 1 by 3. So yes, the center is 1 by 3. So now we have got the center also and its x coordinate. So finally when we write the equation of the ellipse, so I hope you have seen all of this. I am writing it now, and writing it we get x minus, so I am writing it here, x minus 1 by 3 whole square upon a square. A square is 1 by 9 plus y and y minus 1 whole square upon b square. B square is equal to 1 by 12. So it is 1 by 12 is equal to 1. So this is finally equation of the ellipse. Now let us come to the next question. An ellipse is described by using an endless string which is passed over two pins. What it means? It simply means that two pins are the two foci, pin 1, pin 2, and there is an endless string, so it may be like this, and this is the P point, and it is moving. If the axes are 6 cm and 4 cm, so the ellipse is having axis given as 6 cm and 4 cm, which means A is 3 and B is equal to 2. Find necessary length and the distance between the pins. So you have to find PP1 plus PP2 plus P1P2, right? This is the total string, this plus this, and the distance between the pins also, that is P1P2. So what will happen? We take first eccentricity, so B square is equal to A square 1 minus E square. So this will become 1 minus E square is equal to 4 by 9. So E square will be equal to 5 by 9. So E is equal to root over 5 by 3. This is the eccentricity. So we have to find, after finding E, PP1 plus PP2. So even if you don't find E, PP1 plus PP2 is easy to find because it is equal to 2A and 2A is equal to 6. So this is 6. And if you talk about P1, P2, then you have to find E because P1, P2 is 2AE. So this will be equal to 6 into root 5 by 3. So this will become 2 root 5. So finally you will get the total value as 6 plus 2 root 5. And only P1, P2 is 2 root 5. That is the distance between the pins. Now if we talk about the next question, it says P and Q are corresponding points on an ellipse and the auxiliary circle respectively. The normal at P to the ellipse meets CQ in R, where C is the center of the ellipse. Prove that CR is equal to A plus B. So again, if we have an ellipse like this and we have auxiliary circle like this and we have P and PQ are corresponding points. So P is here, Q is here, and then we are saying the normal at P to the ellipse meets CQ in R. So this is CQ and this is normal at P. So this is the normal at P and this is meeting CQ at R like this. Prove that CR is equal to A plus B. So this total length CR is equal to A plus B. So first of all, let us find the equation of the normal to the ellipse. So if ellipse is having point A sec theta, comma B tan theta, which is its, the point is A cos theta, comma B sin theta. That is the parametric point of an ellipse. So equation of the normal. So it is x by x1 A square minus y by y1 B square is equal to A square minus B square. This you have to remember, the equation of the normal to an ellipse. So if we take x1 as A cos theta, so this will be x by A sec theta minus y B, and this will become cosec theta is equal to A square minus B square. And then we have CQ. So Q is A cos theta comma A sin theta. So A cos theta comma A sin theta, this is Q. So equation of CQ if we talk about. So that equation was of the normal PR. Now CQ equation if you want to find. So what will happen? That this is y by x is equal to simply tan theta. So this will give you y is equal to x tan theta. Now let us solve both of them and find the coordinate of R. So if we take y is equal to x tan theta here, so this will become xa sec theta minus x tan theta. That will be sin theta b sin theta by cos square theta is equal to a square minus b square. So what will give you? The LCM would be cos square theta, and this will become x a cos theta minus b sin theta is equal to a square minus b square into cos square theta. So this is this. Now from here you find the value of x. Now you can also find the value of y. So y would be correspondingly a tan x tan theta. So if you find x tan theta, so you will put there tan theta with multiplication. So it will become like this: a cos theta minus b sin theta is equal to a square minus b square cos theta sin theta. So as you can check, if you divide y by x, you will get tan theta. Now if you want to find CR finally, so CR root over x square plus y square. So a cos theta minus b sin theta will come outside of the root, and you take mod, of course, and inside you have cos square theta, and a square minus b square will also come outside, and inside you have cos square theta plus cos square theta sin square theta. So you can take cos theta outside, and it will become 1 plus sin square theta and under root of that, like this. So this is what we are getting here, CR. Now is this a plus b? That you have to find out. So students, if we see here, we are not getting the desired result. What is the calculation error which we may have done here? So if we trace back to our calculation, there are two calculation errors. First calculation error is basically when we replaced y as x tan theta here, y as x tan theta here. So this becomes xb sin theta by cos theta by sin theta. So this sin theta won't be there, and there is one cos theta which will not be there, because sin theta and sin theta will cancel. And this will finally become xa minus xb, and there won't be a cos theta, a by cos theta, and b by cos theta it would be. Similarly here you will find a by cos theta and b by cos theta here also. And then this is fine, these two things are fine. So if we come to here the calculation, so this will be a cos theta and b by cos theta, right? Further we take this one also. So this one is not a square minus b square cos square theta, this is a square minus b square cos theta. Only a square minus b square, because cos theta we are already taking here. So this is not cos square theta. And there also a square minus b square if we are taking, then y is equal to x tan theta. So this will be simply into tan theta. That would be like this. This would be into tan theta. So these calculation errors sometimes happen. So you have to do each and every calculation step by step. I am doing here because the space constraint is also there. I don't want to rub, and because you may lose the trace, that is why I am keeping everything over here. So you have to see here. So a square minus b square tan theta is there. Now if you see the calculation part here, a square minus b square, and this will become 1 plus tan square theta, right? So this cos theta won't be there, this will be 1 plus tan square theta, and under root of tan square theta is sec theta. 1 plus tan square theta is sec square theta, and under root of that is sec theta. So sec theta and cos theta will cancel, this will become a square minus b square, and this will become sec theta, and here also a minus b by cos theta, which is sec theta. So this will be finally a plus b, as a minus b will get cancelled and sec theta will get cancelled. Let us come to the next question. Find the slope of the common tangent of x square plus y square is equal to 16. So slope of the common tangent of this circle, x square plus y square is equal to 16, and x square by 25 plus y square by 5 is equal to 1 in the first quadrant. So another is the ellipse, this one, and this is the common tangent. Also find the length of the intercept made by the tangent between the coordinate axis. So once you will find the equation of the tangent, you will of course find the intercept made by the tangent between the coordinate axis. So what will happen? Let us suppose equation of the tangent to the circle is y is equal to mx minus root over, because its slope is, its intercept is plus. Okay, this is the plus intercept, so plus I am taking, plus root over a square m square plus a square, that is a will be outside and its radius is 4, 1 plus m square. And another equation of the tangent to the ellipse is y is equal to mx plus root over a square m square. So this will be 25 m square plus b square, that is 5, like this. Now both of these tangents are common tangents, that is the common tangent to the ellipse and the circle. So its intercept will be equal. So we say 16 into 1 plus m square is equal to 25 m square plus 5. So what will happen? 25 m square minus 16 m square is 9 m square is equal to 16 minus 5, that will be 11, right? So this will give you m square is equal to root over 11, m square m will be root over 11 by 3. So this is the slope, and we take the negative slope because this is obtuse angle. So minus root over 11 by 3. Now you can find the equation of this tangent after putting the value of the slope and also find the intercepts. So we have the next question. From a point on the axis of x, common tangents are drawn to the parabola y square equal to 4x and the ellipse x square by a square plus y square by b square equal to 1, a greater than b greater than 0, that means it is a horizontal ellipse. So from here we get a diagram something like this, that this is the parabola, this is the ellipse, and there is a point here from where two tangents can be drawn, which are the common tangents, and then we have the chord. If these tangents form an equilateral triangle with their chord of contact with respect to parabola, that means this is the chord of contact with respect to parabola and this is forming an equilateral triangle, then the exhaustive values of A is. So this is the chord of contact. So let us point, suppose this point is minus alpha comma 0 on the x-axis, and the equation of the tangent to the parabola is y is equal to mx plus 1 by m, as a is equal to 1 for y square is equal to 4ax. Here y square equal to 4x is there. Now the chord of contact will be y into 0 is equal to 2 into x minus alpha. So this will give you x is equal to alpha. So this is x is equal to alpha. Now this is an equilateral triangle, that means this is 30 degree. Now if this is 30 degree, then what you can do is, you can see that since this point can be calculated as it is y square equal to 4x and this is alpha, so you put here, then it will become 4 alpha, that is y is equal to 2 alpha here, alpha comma 2 alpha. So you can say that tan 30 degree is equal to perpendicular, which is 2 alpha, upon base, which is alpha and plus alpha 2 alpha again. So this is basically not possible. So this is y square is equal to 4 alpha. So 4 root alpha, sorry. So y square is equal to 4 alpha is there, no? So 2 root alpha is 1. So this is 2 root alpha. So tan 30 degree is 2 root alpha by 2 alpha. So this will become 1 by root alpha. And tan 30 degree is 1 by root 3. So alpha is equal to 3. So this is what we are getting. So this is alpha is equal to 3 and this is minus 3 comma 0. Now in the next step we have to find the exhaustive value on A. So we know that since this is tangent to the ellipse, so of course its intercept will be root over a square m square plus b square, which is equal to 1 by m. Now what is m? M is the slope and m is equal to slope of this tangent is 1 by root 3. So this is 1 by root 3. So this will become a square and m square will be 3 plus b square and this is 1 by m square. So this will be 3. Now from here we know that b square is equal to a square into 1 minus e square. So this is a square by 3. B square is a square into 1 minus e square is equal to 3. Now when we will calculate it, we get a square plus 3a square, 4a square by 3, of course, and minus a square e square is equal to 3. So this is what we are getting. Now from here, can you find e square in terms of a square? So e square will be equal to, if you do the calculation, e square will be equal to 4a square minus 9 by 3. First you write like this, 4a square minus 9 by 3, then by a square. Now this will be less than 1 for the ellipse. So 4a square minus 9 is less than 3a square, which means a square is less than 9, which means a is less than 3. So a has to be less than 3. Two options are there, 0, 3 and 3 by 2, 3. Which option will you take? So a has to be positive. And also the condition on b is there. So similarly you can see what should be the option and you can take. So the upper limit is 3 and lower limit of course will be there, and that you can find out. Now let us come to the next question. Tangents are drawn from any point on the circle x square plus y square is equal to c square to the ellipse x square by a square plus y square by b square equal to 1. So we have this circle and there is an ellipse. This circle is x square plus y square is equal to c square, and this is ellipse, and we are drawing two tangents, and then we have the chord of contact here, and there is the midpoint. So if we talk about this point on the circle, this will be c cos theta comma c sin theta. So the chord of contact will be t is equal to 0. So if we talk about t is equal to 0, so x and c cos theta by a square plus y c sin theta by b square is equal to 1. So this is what we are getting, the chord of contact. Now if we talk about the chord equation with the midpoint, so let us suppose the midpoint is x1 comma y1. So it is t is equal to s1. So t is equal to s1 if you will do, so this will become x1 by a square plus y1 by b square is equal to x1 square by a square plus y1 square by b square, like this. Now these two equations are the equations of the same chord. This equation is obtained by finding the equation of the chord of contact, and this equation is obtained by finding the equation of chord with midpoint x1 y1. Now it is saying find the locus of the midpoints of the chord of contact. So if we compare them, coefficient of x is c cos theta by a square. So this is c cos theta, and here coefficient of x is x1 by a square. So this will be x1. Similarly for y, this will be c sin theta, and this will be y1. And the constant is, here it is 1 by x1 square by a square plus y1 square by b square. Now what we will do, we take cos theta here, and cos theta will be equal to x1 by c upon x1 square by a square plus y1 square by b square. And then what about sin theta? Sin theta is equal to y1 by c by x1 square by a square plus y1 square by b square. Now when we will do this, what will happen? We can do cos square theta plus sin square theta is equal to 1, and we replace this and this there, and we finally get the equation in x1 y1, which will give you the locus of that point, midpoint. That is all for this lecture, students. Thank you.